So ito yung problem natin. We have a cantilever beam with a uniform loading of 2 kips per feet and 3 kips. We have the modulus of elasticity as 29 kSI. We have the moment of inertia as 245 inch to the fourth. And the unknown is the slope at A and the deflection at A. Okay? Using the area moment method or moment area method, we are going to use, para mas madali, the principle of superposition. Ang sinasabi ng principle of superposition is yung deflection ng individual loading, pag pinagsama natin, ay yun pa rin yung deflection ng original figure. Okay? Or ito yung tinatawag natin na moment by parts. Okay? So, kukunin natin yung moment nitong uniformly distributed load. Then, kukunin natin yung moment nung point load. Okay? So, you have here A, this is B, and let's make it C. So, i-abbreviate natin yung C. So, unahin natin yung point load. We have 3 kips. Okay? So, this time, ililipat natin yung support from B to A. So, okay? So, at distance x, which is 0, ang moment natin is equivalent to 0. Kasi 0 times 3 is equivalent to 0. Okay? So, at distance, this is x kasi. The whole of this is x. Okay? That is x. So, at distance x equals to 6, okay, dito, which is B, the moment is equivalent to 3 times 6, or that is 3x. And that is 18. Okay? So, ang moment diagram niya, moment by parts, it would be a triangular load. And that is 18. Negative 18. If we are to recall our loadings, we have point load, uniformly distributed load, and we have the uniformly increasing load. Then after that, you have the parabolic load. Okay? So, pag nag-point load ka, point load ang given sa iyong diagram. Sa iyong shear diagram, it would be a uniformly distributed load, and that is a 0 degree. Then sa moment diagram mo, it would be a first degree, and that is a uniformly increasing diagram. Uniformly increasing load. Pero, if nag-start ka sa uniformly distributed load sa given, katulad nito, sa shear diagram mo, magiging uniformly increasing load. Then sa moment diagram, magiging parabolic na yung shape natin. And this is a second degree curve. Okay? But, kung ito naman yung binigay sa load mo, ito ang lalabas sa shear diagram mo, then sa moment diagram, it would be a 3 degree curve. Okay? So this is a parabolic spandrel. Okay? So, since dito ang load natin is point load, sa ating moment diagram, it would be a triangular load. Okay? Since this is downwards, so negative ang ating shear moment diagram. Next would be our uniformly distributed load. And this is 2 kips per feet. Okay? Take note that this distance is x. Therefore, itong distance na to, it would be x minus 3. Kasi this time, alam natin na this is 3 feet. Okay? So, gawa na natin ng equation. So, section BC. So, section BC, we have moment is equivalent to negative 2 because it is pointing downwards. Negative 2 times yung span niya, which is x minus 3 times the lever arm, which is x minus 3 over 2. Okay? So, magiging x minus 3 squared. So, substituting at x equivalent to 6 kasi 6 meters. Okay? At x equivalent to 6, it would be, this is negative, we have moment is equivalent to negative 6 minus 3 squared. And that is 9, negative 9. So, this is a uniformly distributed load. So, ang magiging moment diagram niya is triangular load. Okay? So, redrawing that, ang magiging itsura na nung diagram natin is ganito. So, from 0 to 9. Negative 9. Then, yung isa naman nating diagram is we have triangular din. Negative 18 for the moment diagram. Ay, mali. This is a uniformly distributed load. So, dapat, ano siya, parabolic. It should be parabolic. It should be parabolic. Okay. And ang parabolic spandrel natin, it is 3 over 4. That is x bar. I repeat, x bar is 3a over 4. That is a. So, the centroid is 3/4 of 3. Then, itong isa, it is 2/3 of 6. Okay? To compute for the slope is equivalent to the area. Area lang. Nung spandrel natin at saka area nitong triangle. So we have, for the area of a spandrel, it is 1/3 of base, which is 3, times height of 9, plus the area of 18, which is, yung triangle natin, we have 1/2 base of 6 times the height of 18. Quantity times 1 over E, I. So, ano yung E natin? E is equivalent to 29,000 PSI. So, 29,000 PSI pound per square inch times, gawin nating feet because this is in feet to make it consistent. 12 inch is 1 foot squared times the moment of inertia, 245 inch to the fourth. So 245 times, that is inch to the fourth times 12 inch is equivalent to 1 foot quantity to the fourth. That is equivalent to 0.00128. Ay, no. That's not in feet. Radian. Para naman dun sa deflection at A, it is simply the area times the lever arm. Okay? So, ano ba yung area natin? Ulitin lang natin. It is 1/3 times 3 times 9 times ang lever arm natin. This time, it is, ito yung x bar natin, di ba? So, that is 3/4 of 3. So, that is 3/4 of 3 plus 3. Okay? So, 3/4 of 3 plus 3 plus, we have, ito naman, 1/2 times the base of 6 times the height of 18 times the lever arm of 2/3 of 6. Divided by EI. So, anong EI natin? 29,000 pounds per square inch times 12 inches equivalent to 1 foot squared times 245 inch to the fourth times 1 foot is equivalent to 12 inch raised to the fourth power. This is equivalent to 263.25 kip feet cube. Okay? So, medyo maliit lang ang makusolve nating value. So, ang papalitan natin ngayon this time is the feet. Gagawin natin siyang inch. So, times 1 foot is equivalent to 12 inch and that is to the third power. And i-retain natin tong nasa denominator. So, 29 times 10 raised to 3 times 245 inch to the fourth, and this is pound per square inch. Okay? And that's it. The answer is 0.064 T. And that is in inch.